Hello friends, this is Shivam and you are watching the 9th tutorial of the data analysis using Python series. And in this tutorial we will be just implementing a linear regression model, and we will just see how it works and what are the basics of implementing a linear regression model. What are the pros and cons of the linear regression. So discussing about the introduction and the various fundamentals about the linear regression, we can say that linear regression is a very fast algorithm and no tuning is required in case of linear regression, and highly interpretable, and it is well understood. It is one of the most well understood algorithm, linear regression. So, and discussing about the cons of linear regression, we can say that there should be no multicollinearity between the different variables. So it is unlikely to produce the best predictive accuracy. So these are the cons of linear regression. Now in this tutorial what we'll be doing is that we will be predicting the sales using the linear regression model, and we have just provided the link to the data set, and we will be using this link. And now describing about the data set, we have the features of the data set as television, radio and newspaper, and we are just trying to predict the sales based on the advertising dollars spent on these three advertisement mode. Like we have done advertisements over television, we have done advertisements over radio, we have done advertisements over newspaper, and based on that we are just trying to predict the sales and how basically the sales are depending on these three variables, on the advertisement, on these three different modes of advertisement. So there are 200 observations within the data, and there are 200 rows, and each observation represents a single market. And we will be also using the package, the Seaborn package, for the statistical data visualization of the data set. So now first of all let's import the various libraries. First of all we will import the pandas as PD, and then we will load the data set as a CSV file, PD, with the help of pandas. PD.read CSV, read CSV, and we have the link over here. We can use this link to get the data set. We can use this link, that's why I put it over here. So this is the link, and we will be reading the CSV file using the pandas from this link. So let's just try to load this data, and it is loaded. Now we will just see the few initial rows of data set using the data.head command. So this is basically the data set and how it looks like. We have the four main columns. We have the three different modes of advertisements like TV, radio, newspaper, and we are just seeing how the sales are dependent on these three modes of advertisements. So now what we will be doing is let us just also see the tail of this data set using the data.tail command, and you can see that. Let us also see the shape of this data, of the data set, and you can see that there are 200 rows and 5 columns. This column is unused. This is just representing the serial number, so we just need not to consider it. And now let us just import the Seaborn package to see how our sales are statistically dependent on these three modes of advertisements, that is TV, television, radio and newspaper. So let us just import the Seaborn package as SNS, and also allow the graphic to appear in the same notebook. So let's matplotlib in line. So these are the things that we have done now, and now we will be creating a pair plot, and we will be just trying to visualize the relationship between the features and the response using the scatter plot, using the pair plot function of Seaborn library. So let us try to build a pair plot where we have the data defined, and we want the x vars to be TV and radio and newspaper, radio comma newspaper, and we want the y variable, y vars to be the sales. That's it. We have defined the x variable with the y variables, and let us give this size to be 7 and aspect to be 0.7. okay, and let us just give the kind. We just want to build a regression plot over here, so we will give the kind as the reg command. So just let us just try to plot it. So here we are. So you can see the regression lines for sales as a function of television, as a function of radio, as a function of newspaper. So this is, you can see that the sales is highly dependent on television, because the linear regression is quite good. It is quite concentrated in a, this line is fitting good to the data points, and on the other hand, in case of radio, it is not as much as better as the television. So, and in case of newspaper, it is again even not better than the radio. So we can see that sales are very much affected because of the advertisements on TV. So this is the test that we wanted to conduct using the pair plot technique. Now we will just try to build a linear regression model using the, so let's pre-process the data set, and let us just prepare some feature columns. So feature calls is equal to, we can copy it from here. We want these columns to be the feature columns, and we want the x is equal to data feature calls, and we just want to print the head of this data. These are the columns that we will be building a linear regression model with. So let us just try to see how the data x is like. We have just taken only these 3 feature columns for our analysis. So x is the data, and in the same way, let us just try to print some information about the x. So let us just try to print the type of x and shape of x. X dot shape. So yes, this is so good. So we have the class of x as the pandas data frame, and the shape is 200,3. So that's good. Now we will create a y, or the target variable, as the data Oops. So this is the y. Oh, we just need to change it again. Yeah. So data, we have just created the target variable, which is the y, and let us just try to print the head of the target variable. So you can see this is here. This is the sales, and the data type is float64. Now let us just try to again print the same thing for the y, that is target variable, the type and shape. The type and shape, print y dot shape. Yes, we are done. So we can see that the shape, the class, the type or the class is same, the pandas series. It was the pandas data frame and it is the pandas series, and the shape, it is containing 200 rows and 3 columns, and it is just containing 200 rows in a single column. So in the next step, what we will do is we will just split the data set into training and testing data set. So we will be splitting the x and y into training and test data sets. Splitting. Yeah. So now for this we will be using the sklearn package. The sklearn or the scikit-learn package is the most widely used machine learning package, and we will just try to import this sklearn package. Import sklearn, and we just want to use the train test split function of sklearn cross validation. So we will be using sklearn dot cross validation, and we just need to change the import to from sklearn cross validation, import train test split. Yes. So now we will be using the train test split function of sklearn cross validation function. Now it takes the following arguments. We just need to put the xtrain and the xtest and the ytrain and the ytest. Xtrain, xtest, comma ytrain, comma ytest is equal to train test split, and we just need to give it two arguments, x, y, and the random state. The random state is equal to 1. Yeah. So we have just split the x and y data set based into xtrain, xtest, ytrain, and ytest. Now we will just try to print the shape of these different test and train data sets, which are also classified into the feature columns and the target columns data set. So now we just try to print the xtrain dot shape and print xtest dot shape, print ytrain dot shape, print ytest dot shape. Now let us just try to print. So we can see that here we are having 150 observations and 3 columns for the train dataset, and for the train target variable dataset we are just having 150 observations. So we will be building our model based on this dataset, and we will be just training our model based on this dataset, and we will just check the efficiency based on this dataset. So first of all, we will be building our model based on the training dataset. So let us just go ahead and let us just try to build a linear regression model. A linear regression model. Now to build the linear regression model, we need to import the linear regression library. We need to import the linear regression function from the sklearn.model linear model function. So let us just try to import it. Import from sklearn dot linear model from sklearn import linear regression. So we have just imported the linear regression model from the sklearn.linear model function, and we will just define. So now we will define the linear reg model as the linear regression model as the linear reg, and we will use this linear regression model. Linear regression model. And now we will just try to, we have just instantiated the linear regression model. Now we will just build the model on the training dataset. So let us just try to fit the model. Let us just try to fill the model. Let us just try to fit the model. Now we will just use the define linreg model dot fit, and we will just give the training dataset x train comma y train. Now we will just fit it. So we have just built a linear regression model, and we have just fitted it over, and now we will just try to interpret the various coefficients of this model. So let us just try to interpret the various coefficients, interpreting various coefficients of the model. Now first of all, we will be printing the intercept linear reg dot intercept, and then we will print the coefficient linreg dot coff. So we can see that the linear regression model, the intercept is 2.87, and the coefficient for these 3 different columns is 0.04 for television, 0.17 and 0.03. So here we can see that what we just were thinking was somewhat different. And now let us just try to pair the feature names with the coefficients Now we can use the list command over here, list and the zip, to get this all together, and feature calls comma linrig dot coff. So let us just see. So for the TV we have the coefficient of 0.04, for the radio we have the coefficient of 0.17, and for the newspaper it is 0.003, which is quite less. And for the radio the coefficient is very high, so the sales are increasing very highly as compared to the TV and television and newspaper. So the radio is increasing a good effect over the sales. So now let us just try to make some predictions based on the test data. Make predictions. Now we will just make the predictions, and we will just ypred linrig. We have this linrig dot predict. We are just trying to predict the X test data. So just try to predict it. We have just tried to predict it. Now we will be just computing. In the next step, we will be just trying to compute the RMSE, that is the root mean square error, RMSE for sales prediction. Based on this RMSE value, we will just define, we will just think that how effective or how accurate the model is. So let us just try to compute the RMSE. We will be needing two functions for this, and we will just have to import these. So we will be importing numpy as np, and from sklearn import metrics. So now we just need to print the mean square error, root mean square error. So print np dot sqrt, because it is root mean square error, so we just need to take the square root of the number. So matrix of the mean squared error. So as mean matrix dot mean. Okay, we haven't just run the matrix, so we just have to type it. Mean squared error, and we will just white test, and we will just find it between the y test and y predict. That is the thing that we want to do to get the RMSE. So ypred. So let us see that what is the RMSE for our model. It is 1.404. Although it is not that much high, but let us see that how can we try to decrease the root mean square error. So now we will be just doing some feature extraction. We have obtained the various coefficients, and we know that the radio is the most significant factor for predicting the sales, and we will just do the feature extraction. Now we know that the newspaper belonged to our model, the previous model that we built, but now we will just try to remove it and see that if the root mean square error decreases. If it decreases, then we will just build our model based on just television and the radio. So let us just try to change the feature columns again to be TV, comma radio, TV comma radio, and let's just x is equal to data feature calls, and now we just want to again use the y as the data dot sales, and we will just again split it into test and train data set. So I think we should copy it from above. Let us copy it from above. Yes. So we are building another model based on just two variables. Let us see how the RMSE becomes on that. Now we will again define the lenrig dot fit, and then we will be using the above the x train and x test that we have just built above. So x train comma x test, and then we will again predict the values, predict the lenrig dot predict x test. So now again we will just try to print the square root, the RMSE value for the SQRT square root for the matrix dot mean squared error. We just want it to be between y test comma y spread. So let us just try to get the RMSE for the another model. Calculating the RMSE for another model. So okay, 11.9. Okay, we just did some thing over here. Dot fit. We just did a syntax error and invalid syntax. We are having a trouble over here, and it is just saying that okay, we just skipped something. So we have fixed it, and now it is saying that again 150,50 x test feature columns. So let us just try to do it again, and we have now created the x and y, and we just want to, we have everything set over here, we have everything, and we just trying to fit the model. Like, did we just lenrig x train? Okay, we just did the huge mistake over here. We just want to predict between the x and y, not between the x train and x test. These are the different dimensions. So these are the different things. So now I think the code looks clean, and now let us run it. So now here is the RMSE value. So now here you can see that for the first model the root mean square error is 1.40, and for the second model it is 1.3879. So you can see that the RMSE value has decreased on removing the newspaper column, the newspaper variable from our data set. So we can say that the second model is more powerful or more accurate in terms of predicting sales as compared to the previous model. So we can say that the new model is more accurate than the previous model. So here we are. We have just built a regression model, and we just try two regression model. First of all, with all the data variables, and then we just removed the variable which was insignificant, and then we just again build another model based on the significant variables, and then we again created a more accurate model. So let's see from starting at what we have done, or how we have implemented the linear regression in this tutorial. So first of all, we imported the pandas, and then we just imported the data set, and then we just see how the data looks like and what are the various features and what we just want to predict. So now then we use the seaborn pair plot function to do some statistical analysis to see how the sales are dependent, and how the sales are dependent on television, on radio, and over the newspaper. So we just here we have concluded that the newspaper isn't a good factor because the data is highly distributed. It is not fitting to the model, the regression model. Then we just pre-process our data set, and we just build the feature columns based on TV, radio, newspaper, and then we just split the data set into the X and Y data for training and testing purposes, and then we build our first linear regression model. And then on predicting the values, we just get the RMSE, the root mean square value, to be 1.40, and then again we just changed the feature columns and considered the TV and radio only as the feature columns, and then we again predicted the RMSE, and that decreases. So this is the way we just implemented a linear regression model. I hope this video is useful, and don't forget to subscribe. Thanks for watching.